Hey guys, welcome back to my channel. So today in this video we'll be seeing another type of interference which happens in wireless systems, that is we have the adjacent channel interference, which is short named as ACI. So in the previous video we saw what was co-channel interference in cells which were in the honeycomb structure. So it happened because the channels got interfered while transmitting the two signals during that path of transmission. So in this video, let's see what is adjacent channel interference and how this happens. So ACI mainly happens due to the signal which are adjacent in frequency. So if it operates within the same frequency levels in two different cells, so it because of that it triggers the ACI, and so it occurs as a reason because of the imperfect the receiver side filters, which allows the neighboring signal frequencies to mix with the actual pass band. So it's like we have some setup like this. So this is a receiver, and if a user is transmitting his signal to this receiver and his receiver is trying to intercept or get that signal, and if there are some other users around at some distance from that receiver and they are also transmitting to some other receivers, so what this receiver does is it will try to pick up the signals which are very near to it, and so you get a problem that's called as a near far effect in this. So that's mainly addressed in ACI, and so if adjacent channel signal strength becomes much stronger, it will be difficult for the base station of the actual cell to differentiate whether the actual mobile signal is coming, that's a strong signal, or whether it's a weak signal. And so there are some factors for reducing ACI. So the very first one is the proper filtering of the receiver side pass bands, and the second one is the channel assignments, where we deploy the frequency reuse technique in order to save the bandwidth, and so that plays a very major role in reducing the ACI. Next, we have in the honeycomb structure various cells of different cluster size. So each cell will belong to a particular cluster zone, and so it will be given, or a set of channels will be allocated. So after that, these channels will be given the frequencies in such a way that the frequency of the adjacent channel will not be close to the any other cell, and hence we can reduce the ACI to a very considerable level. And there is another problem which happens in ACI, that is we already know that frequency reuse technique is used to save the bandwidth, and so if channels in this reuse the same frequency again and again, it may give rise to a major ACI effect. And so let's consider two scenarios. We have two users, user 1 and user 2, and say user 1 is 12 times more closer to the base station, and if user 2 wants to transmit to this base station, then what happens is the user which is more close to the base station will be receiving the signal. And so in this case you have the signal to interference ratio, which is given by 12 raised to minus n, that is the number of time the base station is nearer. So it's like the range or the distance between the base station and the user is determined in this, and so we saw this ratio in the co-channel interference also, in that we had a big equation. This is the equation for ACI we get in this case of scenario. So well, that was all regarding the ACI in wireless systems. So hope you guys enjoyed this video. If you want to got educated by watching this video, please do like, share, comment, and most importantly, don't forget to subscribe to my channel. Thank you very much for watching this video.